Hello everyone, welcome to our channel of campus. In this video we are going to see in EMFT, electromagnetic field theory. In EMFT we are going to check with the multiple choice questions and answers in electrostatics, which will be helpful for you to clear exams like TANCET, TNEB Assistant Engineering and TRB Polytechnic exam, lecturer exam. Previously we have discussed around 100 MCQs in electrostatics. Here we are going to, in this video we are going to see the rest of the question and answers. So if you haven't seen those videos, still kindly check with the playlist. Before starting the video, kindly subscribe our channel Off Campus and click on the bell icon. Then only you will receive notification as in when we upload videos. Let's go into the video. What is the first question? Okay, 101. As I told earlier, previously we have discussed around 100 MCQs in EMFT in electrostatics. Okay, this is the question number 101. What is that? 1 volt is the same as 1 volt, which is equal to 4 different options are given: 1 joule per coulomb, 1 coulomb per joule, 1 coulomb, 1 joule. So what is the formula for voltage? Voltage equal to energy W, work divided by charge, V equal to W by Q. Then what is the unit for voltage? Volts. What is the unit for work? Is nothing but joule. What is the unit for charge? Charge is coulomb. So 1 volt is same as 1 joule per coulomb. Okay, option A, 1 joule per coulomb is the right option for this problem. Next question, the capacitance between two plates increases with 4 different options are given: shorter plate area and higher applied voltage, shorter plate area and shorter distance between them, larger plate area, longer distance between plates and higher applied voltage, larger plate area and shorter distance between plates. So we know the formula for capacitance. What is the capacitor formula? Capacitance C equal to epsilon A by D, where C equal to nothing but capacitance units in farads. Epsilon equal to permittivity of dielectric. It is absolute permittivity, not relative permittivity. Okay. Then what is A? Area of plate overlap in square meters. D, distance between plates in meters. Okay. Then what is given? When the capacitance between two plates increases, the area is increased. Okay, because it is directly proportional with the capacitance. So whenever capacitance is increased, area will be increased. And what about the distance? Distance is in the denominator, so it is inversely proportional to the capacitance. So whenever capacitance increases, the distance between the plates will be decreased. Okay, so whenever capacitance between plates increases with larger plate area and shorter distance between plates. Okay, so option D is the right option for the problem, for this question: larger plate area and shorter distance between plates. Okay, then next question, the capacitance C is charged through a resistance, or the time constant of the charging circuit is given by time constant. What is the time constant formula? Tau equal to R into C. Okay, option C, RC. Time constant equal to RC is the right option for this problem. Next one, the bridge used for the measurement of the value of the capacitance is. Which bridge is used for the measurement of the value of the capacitance? 4 different bridges given: Wayne's bridge, Wheatstone bridge, Shrink bridge, Hayes bridge. Option C, Shrink bridge is used to measure the value of the capacitance. Okay, then move on to the next one. 105. If an ohmmeter reading immediately goes practically to 0 and stays there, capacitor is. Whenever if an ohmmeter reading immediately goes to 0, what is the capacitor? 4 different options is given. The capacitor is short circuited. Whenever the capacitor is short circuited, the ohmmeter reading will go to the 0 and stays there. Okay, option B, short circuited, is the right option. Then question number 106. Out of the following capacitors of identical rating, which one have the smallest dimensions? So, these given in the options, they are all identical ratings. So, which one have the smallest dimension out of the options? Given options is nothing but option C, ceramic capacitor have smallest dimensions. Okay, we will move on to next one. 107. An uncharged conductor is placed near a charged conductor. An uncharged conductor is placed near a charged conductor, then what will happen? The uncharged conductor gets charged by induction and then attracted towards the charging body. Okay, the uncharged conductor, whenever the uncharged conductor is placed near a charged conductor, what will happen? The uncharged conductor gets charged by induction and then attracted towards the charging body. Option B is the right option for this question. Next, question number 108. The presence of an uncharged conductor near a charged one increases the, so uncharged conductor near a charged conductor increases the which will be increased. So, charge of the conductor, capacity of the conductor, potential of the conductor, or all of the above. So, whenever presence of an uncharged conductor near a charged one increases the capacity of the charged conductor. So, option B, capacity of the charged conductor is the right option for this question. Next one, paper condenser is, what is a paper condenser? Paper condenser is option B, usually of fixed value. Paper condenser is usually of fixed value. Then 110, mica capacitors are characterized by all of the following except. So, it is characterized by all of the following except option C, low leakage reactance. Low leakage reactance is the right option for this question. Then 11, this is one problem. A potential of 400 volt is applied to a capacitor, the plates of which are 4 millimeter apart. The strength of electric field is. So, what is given? Voltage value is given and distance given. We need to find out the strength of the electric field. We know the relation between electric field and voltage and distance is nothing but E equal to V by D. What is the given voltage? 400 divided by which one? Here 4 millimeter. 4 millimeter is nothing but 4 into 10 power minus 4 into 10 power minus 3. Okay, 400 divided by 4 nothing but 100. Then 10 power minus 3 is in the denominator. When it will come to the numerator as 10 cube. 10 cube is nothing but 1000. 1000 is represented as kilo. So, kilovolt per meter. 100 kilovolt per meter. Option A, 100 kilovolt per meter is the right option for this problem. Then 1112, for a good 0.05 microfarad capacitor ohmmeter reading should, what is? Option A, show low resistance momentarily and back off to a very high resistance. What will happen? Ohmmeter reading should show low resistance momentarily and back off to a very high resistance. Okay, option A is the right option. Then move on to the next one. The ohmmeter reading for a short circuited capacitor is, whenever, what will happen? Previously we have seen one question now. Whenever ohmmeter reading is practically goes to 0, that means the capacitor is short circuited. Again, the same question is framed in a different format, different way. So, the ohmmeter reading for a short circuited capacitor is nothing but 0. Option D, 0 is the right option. Then 114, which of the following statements is correct? 4 different statements are given. Mica capacitors are available in the capacitance values of 5 to 20 microfarad. Air capacitors have a black band to indicate the outside the foil. Electrolytic capacitors must be connected in correct polarity. Ceramic capacitors must be connected in correct polarity. What is the option in given statements? Which one is the correct? Option C, electrolytic capacitors must be connected in correct polarity. Then move on to the next one, 115. Which of the following capacitor preferred for high frequency circuits? High frequency circuit, option C, mica capacitor is preferred for high frequency circuits. Then 116. An electrolytic capacitor is generally made to provide large value of capacitance. Option D, large value of capacitance is the right option for this question. Then 117. Dielectric strength of a medium. 4 different options are given. Increases with rise in temperature, increases with moisture content, is same for all insulating materials, none of the above. So, dielectric strength of a medium is nothing but from the given statements or from the given options, option D, none of the above is the right option for this problem. Then one problem, 118, a charge which when placed in a vacuum from an equal and similar charge repels with a force of 9 into 10 power 3 Newton is known as. So, we need to find out the charge value. So, we know the Coulomb's law. According to the Coulomb's law, what is the Coulomb's law? Force equal to K. K is nothing but 1 by 4 pi epsilon value. So, into Q1, Q2 divided by D square. D square is distance squared. What is given? Equal and similar charge. Nothing but Q1 and Q2 is nothing but Q only. Okay. Then how to find out the Q from this? Q equal to force into cross multiply. Force into distance square divided by K. Right. What is force here? 9 into 10 power. So, substitute all value 9 into 10 cube divided by we know that distance squared is nothing but, see which one, sorry, a charge when equal and similar force value is given 9 into 10 power cube divided by 1 by nothing but K. K value, K, what is K value? K equal to 1 by 4 pi epsilon. We have one constant value for that K, which is nothing but 9 into 10 power 9. So, equal and similar charge. So, K equal to 1 by 4 pi epsilon naught. So, what is the value for 1 by 4 pi epsilon naught? We have one constant value, that is nothing but 9 into 10 power 9. In the when we cancelling, what we will get? Power 3 minus 9 is 9 and 9 get cancelled. So, we will get 1. 3 minus 9 nothing but minus 6. Minus 6. 1 into 10 power minus 6. What is the value? It is nothing but microcoulomb. Option B, microcoulomb is the right option for this problem. Then 119. In order to remove static electricity from machinery, so 4 different options are given. Construct insulated cabins, insulate machinery, ground the framework, humidify the surroundings. So, in order to remove static electricity from machinery, option C, ground the framework. Okay. Then move on to the next one, 120. If a third equal and similar charge is placed between 2 equal and similar charge, then this third charge will, 4 different options are given. Move out of the field of influence of the 2 charges, remain in stable equilibrium, not be in equilibrium, be in unstable equilibrium. So, if a third equal and similar charge is placed between 2 equal and similar charge, if a third equal and similar charge is placed between 2 equal and similar charge, then this third charge will remain in stable equilibrium. Option B, remain in stable equilibrium is the right option for this problem. Then 121. A region around a stationary electric charge has an electric field and magnetic field, both A and B or none of the above. A region around a stationary electric charge has an electric field. Option A, has an electric field is the correct option. Then 122, the minimum value of potential gradient in a cable occurs in a insulation. So, 4 different options are insulation, conductor, outer sheath, uniformly all over. So, the minimum value of potential gradient in a cable occurs in option A, insulation. Then 123. Dielectric strength of a medium is usually expressed in, what is the unit for dielectric strength? Is a strength of an insulating material with related to the thickness. Okay. Then what is the unit? Kilovolt per millimeter. Option C, kilovolt per millimeter is the dielectric strength of the medium. Then 124. This is one problem. A positive and a negative charge initially 50 millimeter apart. Okay, when they are moved close together so that they are now only 10 millimeter apart, the force between them will be. So initially the positive and negative charge will be in a distance of 50 millimeter, then they are moved close together, so that now what is the new distance is nothing but 10 millimeter. They are close, they are moved to close together, so the distance will be reduced now. So what is the distance now? 10 millimeter. So what we need to find out the new force. Okay, first of all we know the formula for force, q1 q2 divided by 4 pi epsilon naught into r squared. Okay, so F equal to q1 q2 divided by 4 pi epsilon naught. These are all not given, so take this as a constant. Okay, F1 equal to F equal to q1 q2 divided by 4 pi epsilon naught. We have only the distance equal to 50 the whole square. 50 the whole square, this is a constant. I am writing again the same one, q1 q2 divided by 4 pi epsilon naught. 50 square is nothing but 2500. Okay, this value. Then what is the new force now? It is what is the distance is changed to 10 square. So just change the distance square. 10 square is nothing but 100. So what is the change here? 25 times. Okay, 1 by 25 times this is 1 by F new is nothing but 1 by 25 of this old one. Okay, right? When this distance is in the denominator, right? 25 times, see here 2500, 2500, here only 100. So whenever the distance we moved close, when we reduce the distance, the force will be increased by 25 times, because the new force equal to 1 by 25 into that old force only. Sorry, old force equal to 1 by 25. Sorry, old force equal to 1 by 25 into new force, right? Say, I am writing here. Say it is as old force. What is the value of old one? Old one is 1 by 25, 1 by 25 in the 1 by 25 of 1 divided by 25 this one, right, equal to new force, right? So, because 1 by 25 times the new force only. So 1 by 25 old force equal to new force. Then force between them will be 25 times larger than before. Old force is whenever it is in the denominator, right? So it is whenever the distance is reduced, so what will be? It is 25 times greater than the before. Okay, new force is nothing but 25 times greater than before, right? Because it is in the denominator. See, 25 is in the denominator, so the value will be reduced. The new force is 1 by 100 only. So the which one? 25 times greater than the, sorry, it is 25 times new force is 25 into 100. New force is 25 into that old force is nothing but new force. So 25 times larger than before. Option D is the right option. Then 125 problem. Which is the most superior dielectric out of the following is nothing but air, glass, backlight, paper. Which is the most superior dielectric is nothing but option C, backlight is the right option. Then 126, when a dielectric is placed in an electric field, the electric field strength decreases. Whenever a dielectric is placed in an electric field, the field strength will be decreased. So option A, decreases. Then next question, the to prevent the generation of static charges on a rubber or flat leather. What will happen to prevent the generation of static charges on a rubber or flat leather surface is moistened? What we need to do? 4 options are given. Conductive dressing is done, oil compound dressing is done, talcum powder is sprayed on the surface. So what we need to do to prevent the generation of static charges on a rubber or flat leather? Option B, conductive dressing is done. Then 1 to 8, which of the following capacitor is preferred in case of a single phase motor? Mica capacitor, paper capacitor, electrolytic capacitor, ceramic capacitor. For in case of a single phase motor, option C, electrolytic capacitor is the right option for this problem. Then question number 129. A capacitance is a circuit component that opposes the change in circuit. Okay, a capacitance is a circuit component that opposes the change in circuit current, circuit voltage, circuit impedance, or none of the above. The capacitance opposes the sudden change in the voltage. Option B, voltage is the right option for this question. Then 130, a condenser suitable for DC only is. 4 different options are given. Which one is suitable for DC only is nothing but option D, poled aluminum electrolytic condenser. Okay. Then 131, and this is the final and last question. In a capacitor, the electric charge is stored in, options are given, metal plates, dielectric as well as metal plates, none of the above. So in a capacitor, the electric charge is stored in dielectric. Option B, dielectric is the right option. So we have seen totally around 131 multiple choice question and answer in electromagnetic field, which is under in electrostatics. Okay, if you haven't seen those videos, still kindly subscribe our channel Off Campus and click on the bell icon. You will receive notifications as and when we upload videos, and check with the playlist. Okay, thanks for watching. Like, share and subscribe.